So today let's discuss questions related to cone that are being asked in previous year. So the question 1 says that find the vertex of this cone. So we are only supposed to find the vertex of cone, but since it's a 15 marker, so first let us prove that the given conic represents a cone, and then we'll move ahead to find the vertex of cone. So we know that general equation of conic, that is ax square plus by square plus cz square plus 2fyz plus 2g xz plus 2h xy plus 2ux plus 2vy plus 2wz plus d equals to 0 represents a cone if determinant of a, b, c, d H, G, G and F is equals to 0. So what we'll do is we'll just compare the given equation of cone with general equation of conic and substitute the values of A, B, C, D and other constants coefficient here. So if we compare, we'll get our A as 2, B as minus, A as 4 sorry, B as minus 1, C as 2, H as 1, G as 0, F as minus 3 by 2, U as 6, V as minus 11 by 2, W as 3 and D is equals to 4. So we'll just put in this equation and see if our determinant comes out to be 0. So if we substitute, we'll get 4 minus 1, 2 and again 4. H is our 1, G is 0, F is minus 3 by 2, U is 6, V is minus 11 by 2 and W is 3. So let us just expand this and see what we'll get. So it is equivalent to 4 into determinant of minus 1, minus 3 by 2, minus 11 by 2, minus 3 by 2, 2, 3, minus 11 by 2, 3, 4, minus 1 minus 3 by 2, minus 11 by 2, 0, 2, 3, 6, 3, 4. Again plus of 0 into the minor with respect to that, but that won't contribute, so we'll not count that, calculate that. Further it will be equals to minus 6 minus 1 minus 3 by 2, 0 minus 3 by 2, 2, 6 minus 11 by 2, 3. So that will be basically equals to 4 into, you can also use calculator, but since we are doing it manually, so let's just find out what we get. 8 minus 9, that will be minus 1, plus 3 by 2 into minus 12 by 2 plus 33 by 2 minus 11 by 2 into minus 9 by 2 plus 11 by 2 minus of 1 into minus 1 again plus 3 by 2 into minus 6 3s are 18 and minus 11 by 2 into 0 minus 6 2s are 12 minus 6 into 1 into minus 9 by 2 plus 11 by 2 plus 11 only, it will be 11. Likewise earlier also I think it will be 11 here. Yeah, plus 1 into 0 minus 12 minus 3 by 2 into 0 minus, it will be plus 9. So let's simplify it and see what we'll get. It is 1 plus 3 by 2 into 33 minus 12 is equals to 21, I guess. It is 21 by 2 minus 11 by 2 into 22 minus 9, which is basically into 13 by 2, minus of minus 1, so 2 balances out this as 9, minus 27 plus 2 balances out this as 6, plus 66, minus of 6 into 22 minus 9, again 13 by 2, minus 12, minus 9 3s are 27 by 2. So let's simplify it further and see what we get. So we'll get 4 plus 3 into 21 minus 11 into 13, that is basically minus 76 by 4, minus of 66 minus 27 minus 1, that is basically 38, minus 13 minus 24 minus 27, which is minus 6 into minus 38 by 2. And if I calculate it, I'll get minus of 76 minus 38 plus 3 into 38. This is equals to 0. So since we got this as 0, so the given equation of as 2-degree conic represents a cone. So now let us find out equation of a vertex of the cone. So the given equation is 4x square f x y z comma t. So we'll just homogenize the given equation and then we'll use the standard method. So given equation is 4x square minus y square plus 2z square plus 2xy minus 3yz plus 12x minus 3yz plus 12x minus 11y plus 6z plus 4 plus 6z plus 4 equals to 0. So if let my t is equals to 1, so the given homogeneous equation will be x y z comma t is equals to 4x square minus y square plus 2z square plus 2xy minus 3yz plus 12xt minus 11yt plus 6zt plus 4 equals to 0. And we know that vertex of a cone can be found out by simultaneously solving the partial differential equations. These equations are del f by del z equals to 0 and del fy del t equals to 0. So let us see what we got after solving this. So we'll get 8x plus 2y plus 12t is equals to 0. From second one we'll get minus 2y plus 2x minus 3z minus 3z minus 11 t is equals to 0. Likewise from third one we'll get 4z minus 3y plus 6t is equals to 0. And from fourth one we'll get 12x minus 11y plus 6z. Here also we'll get t square, 6z plus 8t equals to 0. So if we solve these equation, we'll get okay, so since our t is equals to 1, so from here we'll get 8x plus 2y plus 12 equals to 0. Likewise, from second one we'll get 2x minus 2y minus 3z minus 11 equals to 0. And from third one we'll get 0x minus 3y plus 4z plus 6 equals to 0. So what we can do is we can just calculate value of from here, then can substitute in it to get that value. So from here we'll get 8x as, because y is common in both, so let's just reduce it to equation of y. So I got my 8x as minus 12 plus 2y and my x as minus 12 upon 2y by 8. Likewise, from third equation I got my 4z as minus 6 plus 3y, and from here I got my z as minus 6 plus 3y by 4. So if we just substitute it in the above equation, we'll get 2 into minus 12 minus 2y by 8 minus 2y minus 3 into minus 6 plus 3y by 4 minus 11 equals to 0. So if we solve it, we'll get minus 12 minus 2y minus 8y plus 18 minus 9y minus 44 equals to 0. So if I simplify it, I'll get 8 minus 2 10 minus 9 minus 19y and 18 minus 12 6 minus 44 minus 38 equals to 0. So from here I got my y as minus 2, and I can just substitute this value of y in x. So I got my x as 12 minus 4, 8 by 8 as minus 1, and my z as minus 12 by 4, so minus 3. Now we need to check if these equation of x, y and z satisfies the fourth equation as well. If it satisfies, then the x, y, z coordinates basically represents the vertex of the given cone. So if we just substitute these values there, so we'll get 12 into minus 1 minus 11 into minus 2 plus 6 into minus 3 plus 8 times t, which is basically 1. So this is equals to minus 12 plus 22 minus 18 plus 8. So minus 12 plus 22 is 10, and minus 18 plus 8 is minus 10, which is basically equals to 0. So our vertex of cone is minus 1, minus 2, minus 3 is basically the vertex of the given cone. So let us move on to next question. So the next question says that a variable plane is parallel to this and meets the coordinate axis at A, B and C respectively. Prove that the circle ABC lies on this cone. Okay. So first we'll see what will be the equation of plane parallel to the given plane. So the given plane is x by A plus y by B plus z by C is equals to k. And any equation of plane parallel to this will be is equals to 0. So any equation of plane parallel to given plane will be x by A plus y by B plus z by C equals to k. So let us name it as star 1. So star 1 basically meets the coordinate axis at A, B and C. So we can find out coordinates of A, B and C by checking, because at x-axis we have y equals to 0, z equals to 0. So we got our A coordinate as a, 0, 0. Likewise we got our B coordinate as 0, b, k, 0, and C coordinate as 0, 0, ck. So we are supposed to prove that the circle ABC lies on this cone. Okay, so we can find out equation of circle ABC. So our circle ABC will be, ABC circle is basically is intersection of a sphere OABC and the plane star 1. So first let us just find out the equation of sphere, which will be basically passing via OABC. So equation of sphere via OABC will be, we know general equation of sphere as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus t equals to 0. So if we substitute O coordinates of O, then we'll get our d as 0. Likewise, if we substitute A coordinate, we'll get a square k square plus 2u ak equals to 0. So from here we'll get our 2u as minus ak. Likewise, on substituting B coordinate, we'll get 2v as minus bk, and on substituting C coordinate, we'll get 2w as minus ck. So our equation of sphere via OABC is x square plus y square plus z square minus 2 minus akx minus by minus bky minus ckz is equals to 0. So therefore equation of circle ABC is basically x square plus y square plus z square minus ax plus by plus cz into k equals to 0, and x by a plus y by b plus z by c is equals to k. So these two equations together represents equation of circle ABC. So we are supposed to prove that the circle ABC lies on this cone. So this is basically acting as the guiding curve. So we know that general equation of cone is basically homogeneous. So the equation of cone will be z square minus ax plus by plus cz into x by a plus y by b plus z by c is equals to 0. So we have basically substituted value of k in the equation of sphere to make the equation homogeneous. So if we simplify it, we'll get x square plus y square plus z square minus x square plus b by a xy plus c by a xz plus a by b xy plus y square plus b plus c by b yz plus c by b yz plus a by c zx plus b by c yz plus z square is equals to 0. So if we simplify it further, we'll get b by a plus a by b into xy. We have combined the coefficient of similar terms of similar variables, and likewise xz, if we combine, we'll get c by a plus a by c, and if we combine yz, so we'll get c by b plus b by c into yz is equals to 0, and this y square balances out this one, likewise z square balances on this one, and x square balances the minus x square there. So this is basically the required equation of cone which is passing, this is basically the equation of cone which lies on basically the circle ABC. So now let's move on to next question. So next question says that find the equation of cone whose vertex is 1, 2, 1 and which passes through this circle. So we know that if this is our cone, so this is basically our vertex P 1, 2, 1. Also they have given us the base curve which is basically this one, and the base curve is basically intersection of this sphere and the plane. So we are supposed to find the equation of curve. So since they have given us the vertex of the cone, so we can find any arbitrary line which is passing through the vertex of cone. So P 1, 2, 1 is vertex of cone. So any line passing via vertex, so any arbitrary line passing via vertex will be x minus 1 by L equals to y minus 2 by M equals to z minus 1 by n, where L, M, N we are taking as direction cosines of the line which is passing via vertex. So we can find out any arbitrary point on the vertex. So let us name it as Q, let's say. So any arbitrary point will be LR plus 1, MR plus 2, NR plus 1. So if the given line, the line which we have found out is basically generator of cone, then these are basically this is basically the parametric form of any arbitrary point on generator. So if this is my generator, then it must intersect the guiding curve somewhere, that is the base curve somewhere. So point Q must satisfy the equation of base curve because at somewhere it will be intersecting the base curve to form cone. So if we substitute these value of Q in the base curve, we'll get LR plus 1 square, MR plus 2 square plus NR plus 1 square equals to 5. If we simplify it, we'll get R square as L square plus M square plus N square plus 2R into L plus 2M plus N plus 1 plus 4 plus 1 minus 5 equals to 0, which is basically equals to R square into L square plus M square plus N square plus 2R into L plus 2M plus N plus 4 plus 1 is equals to 0. Likewise, it must satisfy the second equation of plane as well, because intersection of sphere and plane together represents the guiding curve. So if we substitute coordinates of Q in the equation of plane, we'll get LR plus 1 plus MR plus 2 minus NR plus 1 is equals to 1. So if we simplify it, we'll get R into L plus M minus N plus 1 plus 2 minus 1 minus 1 is equals to 0. So we'll get R as minus 1 upon L plus M minus N. So from here I'll got my R as 1 upon N minus L minus M. So this is my R. So basically we're supposed to eliminate this R to find out the equation of plane. So if what I can do is I can just substitute value of this R in star 2. So if I do that, we'll get 1 upon N minus L minus M square into L square plus M square plus N square plus 2 upon N minus L minus M into L plus 2M plus N plus 1 is equals to 0. So if I simplify it, I will get L square plus M square plus N square plus 2 L plus 2M plus N into N minus L minus M plus N minus L minus M square equals to 0. So we can simplify it further. So let us do that. L square plus M square plus N square plus 2 into Ln plus 2Mn plus N square minus L square minus 2Lm minus Ln minus Ml minus 2M square minus Mn plus N square plus L square plus M square plus 2 minus 2NL plus 2Lm minus 2Mn is equals to 0. I have just opened it the whole square and just multiplied these two terms together. So let's see if we can balance out some term. So we are left with L square plus M square plus N square plus 2 times Mn minus 3Ml plus N square minus L square minus 2M square plus N square plus L square plus M square minus 2NL plus 2Lm minus 2Mn equals to 0. So if we see that this 2Mn balances out this one, and L square plus L square balances out this 2L square, I guess that is it. Yeah, so we are left with M square minus 4M square, 4 because this 2 will take this 2 as well inside. So M square minus 4M square plus M square. So we are left with minus 2M square. Likewise N square plus 2N square 3 plus 4N square plus 4N square minus 6ml plus 2ml here, so minus 4ml and minus 2nl equals to 0. So if we can just eliminate these values of m, n, mn and l, we'll basically get the equation of cone. So we can eliminate value of m, n and l here, so because they are in same ratio, so I'll get 2 into y minus 2 square plus 4 into z minus 1 square minus 4 into y minus 2 into x minus 1 minus 2 into z minus 1 into x minus 1 is equals to 0. So this is basically the required equation of cone, which has a vertex as 1, 2, 2, 1, 2, 1, and this as our base curve. So you can also simplify it further, but that just required opening the whole square, so you can do that yourself. So let's now move on to next question. So the next question says that this plane meets the coordinate axis A, B and C respectively. Prove that equation of cone generated by lines drawn from origin to meet the circle ABC is this. So this is basically the repeated question. So from here you can just find out coordinates of ABC. So earlier we have assumed it equals to k, and if you just put k is equals to 1, so you'll get this. We are supposed to prove that equation of cone generated by, so here they have given equation of, you can find out equation of sphere OBC and equation of sphere OABC and the given plane is ax plus by plus cz equals to 0. So if this is, let's say, our cone sphere, so this will be basically the equation of plane. So this is a guiding curve. So we are just, they have given us that we are supposed to find equation of cone which is generated by lines drawn from origin to the sphere, to the circle. So you'll assume this as base circle and then you can go ahead with that. So let's move on to next question. So the next question says that find the equation of cone with 0, 0, 1 as vertex and this as the guiding curve. So if 0, 0, 1 is my vertex, so I can find out equation of line via 0, 0, 1 and L, M, N as a direction cosine. So equation of any such line will be basically x minus 0 by L, y minus 0 by M and z minus 1 by N. Further it says that the equation of cone passes via 2x square minus y square equals to 4, z equals to 0. So this is basically our base curve. So if this acts as generator, so it must intersect with the base curve somewhere. So if it intersects with base curve, then there at intersection point z will be basically equals to 0. So we'll just substitute z equals to 0 in this equation of line. So we'll get x by L equals to y by M equals to 1 by N. So from here we'll got our x as minus L by N, y as minus M by N, and z is equals to 0 as we have assumed. So any arbitrary point on base curve is basically x equals to minus L by N and y equals to minus M by N. So we can just substitute these value of x and y in this to find out a relation. So that will be basically 2 into minus L by N whole square minus M by N whole square is equals to 4. So if I simplify it, I'll get 2L square minus M square is equals to 4N square. So now I just need to eliminate value of L, M and N here to find out the equation of cone. So I can eliminate L, M and N using the general equation of line passing via vertex that we assumed. So our L is basically x, so it is 2x square, y is y minus 2y square is equals to 4z minus 1 whole square. So this is basically required equation of cone. Required equation of cone. Now let's move on to next question. So the next question says that find the equation of cone, equation of right circular cone with vertex as origin. So vertex is 0, 0, 0 and whose axis makes equal angle with the coordinate axis, and generator is the line passing through origin with direction ratio 1, minus 2, 2. So 0, 0, is vertex. So it further says that axis makes equal angle with a coordinate axis x, y, z. So if that is the case, then our direction cosines of axis will be 1, 1, 1 because it makes equal angle with all three axes. So this is basically the direction cosines, and actual direction cosines will be basically 1 by root 3, 1 by root 3, 1 by root 3. You can calculate these by assuming this as 1, and we know direction cosines of x-axis is 1, 0, 0 and y is 0, 1, 0, likewise 0, 0, 1 of z-axis. So you can use these two informations together to find out this, because it makes equal angle with all the three axes. Further it says that direction ratios of generator line of any generator line as 1 comma minus 2 comma 2. So its direction cosines will be basically 1 by under root 1 plus 4 plus 4, which is basically 1 by 9, comma minus 2 by 3, it is minus 2 by 3 and 2 by 3. So basically direction cosines of generator are 1 by 3 comma minus 2 by 3 comma 2 by 3. And we know that if this is our cone, let's say, and it has this as axis, so this angle is theta, basically the angle between axis and the generator. So from here I can find out my angle theta. So basically my cos theta will be 1 by 3 root 3 minus 2 by 3 root 3 plus 2 by 3 root 3. This balances out this one. So I got my cos theta as 1 by 3 root 3. Further, I know that if I assume this is my origin as vertex 0 comma 0 comma 0, if I assume any point P x comma y comma z on the generator line, then also I can find out my angle cos theta. So then my angle cos theta would be, because since I have any arbitrary point P on the generator and vertex is given, so direction cosines of OP will be basically x comma y comma z. So my cos theta will be, and this divided by distance OP. So my cos theta again will be x x by root 3, right? X by root 3 plus y by root 3 plus z by root 3 and whole divided by distance OP. So I can just compare these two values of cos theta. So I'll get 1 by 3 root 3 is equals to x plus y plus z by root 3 divided by distance OP will be basically under root of x square plus y square plus z square, that we can calculate using the distance formula. So if I simplify it, I will get x square plus y square plus z square equals to 9 into x plus y plus z whole square and if I simplify it further, I'll get my equation of cone as 9 into x plus y plus z whole square minus x square minus y square minus z square equals to 0. And on further simplifying it, I'll get 8x square plus 8y square plus 8z square plus 18xy plus 18yz plus 18zx is equals to 0. And that can be further simplified as 4 into x square plus y square plus z square plus 9 xy plus yz plus z is equals to 0. So this is basically my required equation of cone whose axis makes equal angles with coordinate axis and vertex is given to us as 0 comma 0 and whose direction cosines of one of the generator is 1 comma minus 2 comma 2. So let's move on to next question. So the next question says that a plane x by a, y by b plus z by e cuts the coordinate axis at a, b and c. Since equation of plane is given, so we can easily find out coordinates of a, b and c. It further says that find the equation of cone with vertex as origin and guiding curve as circle passing through a, b, c. This is again a repeated question. So we have done the similar question above. So our guiding curve will be basically intersection of sphere OABC and the given plane. That will be basically the circle formed by intersection of sphere OABC and the plane. So using that you can easily find out equation of the required cone. So let's move on to next question. So the next question says that prove that the equation a x square plus by square plus cz square plus 2uxb represents a cone if this satisfies. So we are supposed to prove that this equation represents a cone if this relation satisfies. So as we have seen that general equation of cone, that is basically ax square plus by square. Let's write it as capital A to differentiate it from the given equation. By square plus cz square plus 2fyz 2gxz plus 2hxy plus 2ux plus 2vy plus 2wz plus d equals to represents a cone if this satisfies. A, B, C, D, H, G, F, U, V, W and U, V, W is equals to 0. So if this satisfies, then the given equation basically represents a plane. So if we compare it with given equation of plane, we'll get our capital A as small a, capital B as small b, capital C as small e. And since there are no terms involving yz, zx and xy, so f equals to g equals to h is equals to 0. Likewise, we got our capital U as small u, capital V as small v and capital W as small w. So if we just substitute in the above relation, we'll get also capital D as small d. So we'll get A, B, C, D, U, V, W, U, V, W and rest terms are 0 basically. So we are just supposed to see if what this comes out to check if our given equation represents a cone. So if we simplify it, we'll get A into B0V 0CW VWD minus U into 0B0 00C UVW. If I further simplify it, I'll get A into B into CD minus W square plus V into minus CV minus U into minus B minus CU, which is basically equals to AB into CD minus W square minus ACV square minus BCU square, which is basically equals to ABCD minus ABW square minus ACV square minus BCU square, and they have given us D as D is equals to U square by A V square B, so which is equals to ABCD, and the ABC into D is given as U square by A plus V square by B plus W square by C minus ABW square minus ACV square minus BCU square, which is basically equals to BCU square it will be BCU square plus ACV square plus ABW square minus ABW square minus ACV square minus BCU square. So it turns out to be 0, so which is equals to 0. So the given equation represents cone if U square by A plus V square by B plus C square plus W square by C is equals to D. You can solve it via another method as well. So what you can do is you can just convert the given equation into homogeneous equation by substituting t is equals to 1, and then given equation will turn out to be ax square plus by square plus cz square plus 2uxt plus 2vyt plus 2wzt plus dt square equals to 0. And like we find vertex of the cone by finding out the vertex. So what you can do is you can find del f by del x equals to 0, del f by del y equals to 0, likewise del f by del z equals to 0, and del f by del t equals to 0. And then you can just solve these equations to get a relation, and that will be this relation only. So you can do that as well. So let's move on to next question. So the next question says that prove that the equation this represents a cone with this as vertex. So there are basically two questions. First, we are supposed to show that this represents a cone, and second, we are supposed to find vertex of it. So first, let us see if this represents a cone. So if we compare, we'll get a as 2, b as -1, and c as 1, f as -3 by 2, g as 0, h as 1, u as 6, v as -11 by 2, w as 3, and d is equals to 4. I guess this is the same question, the first question that we did. Let's check if that's the case, because values are similar, I guess. Not this one. So here equation of cone is, yeah, this is the similar question, and here they have asked us to find basically the vertex. So that is basically a repeated question. So we have done this question earlier, so we can move on to next question. So this one also is a repeated question. So here you can do is you can just substitute value in a, b, c, d, and u, v, w, h, g, f, and you can equate it with 0. If you substitute these value here, you will see that this determinant turns out to be 0, and then further you can find out vertex by calculating del f by first converting it into a homogeneous equation by taking t equals to 1, and then solving del f by del x, del f by del z equals to del f by del t equals to 0. So from here you'll get basically 4 equations in x, y, z, and t, and you can solve any 3 equation by putting t equals to 1 and then verify the values of x, y, and z by substituting it in the fourth one. So you'll get this as vertex. So this is basically a repeated question. So let's move on to next question. So in next question we are supposed to show that a cone has its guiding curve the circle this. So basically guiding curve is guiding curve x square plus y square plus 2ax plus 2by equals to 0, comma z equals to 0. So this is my guiding curve and passes through a fixed point. So cone passes via 0, 0, c. So do not make this mistake of assuming this as 0, 0, c as vertex, because it has not given it specifically. It says that this is any arbitrary point via which the given cone passes. So further it says that if the section of cone by plane y equals to 0, so section of cone via y equals to 0 is rectangular hyperbola. It asked us to prove that vertex lies on this fixed surface. So we are basically supposed to prove that this is basically the locus of our vertex. So what we can do is we can assume any arbitrary vertex of cone and then we can move ahead. So let us do that. Let alpha, beta, gamma be vertex of cone. So if this is vertex of cone, and let L comma M comma N be a generator of any line passing via vertex. So equation of that line will be equation of generator line. Equation of generator line would be x minus alpha upon L equals to y minus beta upon M equals to z minus gamma upon N. So if this is my generator line, so this must intersect the guiding curve somewhere. So if it intersects guiding curve, then z must be equals to 0. So I'll just substitute z equals to 0 in this equation. I'll get x minus alpha by L equals to y minus beta by M equals to 0 minus gamma by N. So from here I can find out value of x and y as well. So my arbitrary point will be x will be basically alpha minus L gamma by N comma beta minus M gamma by N comma 0. So this is basically the intersection point of guiding curve z equals to 0 and the generator line that we have assumed. So if this is basically point on guiding curve, then it must satisfy this as well. So we'll just substitute this in there. So we'll get alpha minus gamma L by N square plus beta minus gamma M by N square plus 2a alpha minus gamma L by N plus 2b beta minus gamma M by N equals to 0. So this is basically the equation of our cone L, M and N. Further we can eliminate these values of L, M and N to find the equation of cone. So eliminating L, M and N. So what we'll get is alpha minus gamma into L by N will be, my L by N will be x minus alpha upon z minus gamma whole square plus beta minus gamma into my M by N will be basically y minus beta upon z minus gamma whole square plus 2a alpha minus gamma into L by N, which is basically x minus alpha upon z minus gamma plus 2b into beta minus gamma into y minus beta upon z minus gamma is equals to 0. So if I simplify it, I will get alpha z minus gamma x whole square plus beta z minus gamma y whole square plus 2a alpha z minus gamma x into z minus gamma plus 2b into beta z minus gamma y into z minus gamma is equals to 0. So this is basically my required equation of cone. But we are not supposed to find the equation of cone. We are supposed to find locus of the vertex. So then the in question itself it further says that the cone passes via 0, 0, c. So if this cone passes via 0, 0, c, we'll get alpha c whole square. Let's name it as star. So star passes via 0, 0, c. We'll get alpha plus c whole square plus beta c whole square plus 2a alpha c into c plus 2b beta c into c equals to 0. So if we solve it, we'll get c square into alpha square plus beta square plus c square into 2a alpha plus 2b beta equals to 0. which is basically equals to alpha square plus beta square plus 2a here it will be, yeah, because then we'll get only the previous equation. So it will be basically c minus gamma plus 2b into beta c into c minus gamma is equals to 0. So if I simplify it, I'll get c square into alpha square plus beta square plus 2c into a alpha plus b beta into c minus gamma is equals to 0. So this is basically one equation. Let us name it as star 2. Further it says that the section of cone via y equals to 0 is basically rectangular hyperbola. So if we just put y equals to 0 in this equation, we'll get alpha z minus gamma x whole square plus beta z whole square plus 2a alpha z gamma x into z minus gamma plus 2b beta z into z minus gamma equals to 0. So this is basically section of cone with respect to y equals to 0. So it says that this is rectangular hyperbola. So if it is rectangular hyperbola, then coefficient of x square plus coefficient of z square is equals to 0. Rectangular hyperbola in xz plane, because we have already put y equals to 0. So coefficient of x square from here we'll get as gamma square, only gamma square, plus coefficient of z square will be alpha square plus beta square plus 2a alpha plus 2b beta is equals to 0. So this must also be equivalent to 0. So I got two equations in basically alpha, beta and gamma. So my locus will be, locus of vertex alpha, beta, gamma will be basically c square into x square plus y square plus 2c into c minus z into ax plus by equals to 0 and z square plus x square plus y square plus 2ax plus 2by equals to 0. These two equations basically represents the locus of vertex. So what we can do is we can further simplify it, I guess. So what we can do is from here we can divide throughout with c, so we'll get rid of that. So what we can do is we can just multiply it with c and just can eliminate other two equations as well. So let's see that. So I got these two equations as locus. So what I can further do is I can just multiply with c in this equation and subtract it from the other one. So what I'll get is cx square plus cy square plus cz square plus 2ac x plus 2bcy minus the previous one, that is this one, which is cx square minus cy square minus 2c minus z into ax plus by equals to 0. So if I simplify it, I will get cz square plus 2acx plus 2bcy minus 2acx plus bcy plus 2z into ax plus by equals to 0. So these two terms balances out with this one. So we'll get cz square plus 2z ax plus by equals to 0. So, and we are supposed to prove our locus as this term and x square plus y square. Okay, so we are almost there. Yeah, which is basically equals to cz plus 2ax plus 2by equals to 0. So this term, let's name it as star 4, and this term star 3 basically together represents the locus. So star 3 and star 4 together represents locus of vertex of cone. So let's move on to next question. So the next question says that variable plane is parallel to this plane and meets the axis in A, B and C respectively. Prove that the circle ABC lies on this cone. So this is basically a repeated question. Because we can assume any plane parallel to this as x by a plus y by b plus z by c equals to k. Then we can find out coordinates of a, b and c, and further we can find out equation of circle ABC, because that will be basically intersection of this plane with sphere OABC, and using that we can solve this. We have done this question in today itself previously, so you can refer that. So the next question is, prove that the second degree equation represents a cone whose vertex is this. So if we compare it with general equation of cone, we'll get r small a as 1, small b as minus 2, c as 3, d as minus 20, f as 5 by 2, g as minus 3, h as minus 2, u as 4, v as minus 19 by 2, and w as minus 1. So we supposed to see if the determinant of 1, minus 2, 3, minus 20 into 4 minus 19 by 2 minus 1, 4 minus 19 by 2 minus 1, 5 by 2, no, here it is h, minus 2, g as minus 3, and h as 5 by 2. So we are supposed to check if this determinant is equals to 0. If this comes out to be equals to 0, then our given equation represents a cone, and further we are supposed to find its vertex. So what we can do is, rather than calculating the determinant, we can just reduce it to row reduce echelon form and see if what it comes out to be. So it is basically 1 minus 2 minus 3 4, because row, it doesn't, elementary operation doesn't change its nature, so it is basically equals to 0. Here I have used r2 as r2 plus 2 r1 minus 6, 5 by 2 minus 6, and minus 9 by 2 plus 8. R3, I'm using another elementary operation, R3 as R3 plus 3 R1, which is 0, 5 by 2 minus 6, 3 minus 9, minus 1 plus 4 3 is 12, and R4 I am using as R4 minus 4 R1, that will be 0, minus 19 by 2 plus 8 minus 1 plus 12 minus 20 minus 16. So which is basically equals to 1 minus 2 minus 3 4, 0 minus 6, 6 2s are 12, minus 5 minus 7 by 2, and 8 2s are 16 minus 19 minus 3 by 2, 0 comma minus 7 by 2 minus 6, it is 11, 0 comma 18 minus 3 by 2, 11 minus 36, which is further equals to 1 minus 2 minus 3 4. I am using R2 as R2 divided by minus 6, so that is basically 0 1 7 by 12 and 3 by 12, and here 0 minus 7 by. Now further I am using R3 as R3 plus 7 by 2 R2, so this will be basically 0, and minus 6 plus 7 by 12 into 7 by 2, so I got as minus 6 into 24 plus 49 by 24, that is basically equals to minus 6 plus minus 6 into 24 plus 49, basically minus 95 by 24, and another term will be basically 11 plus 7 by 2 into 3 by 12, so that is 11 into 24 plus 21, 285 by 24. Likewise I am using operation R3 as R3 plus 3 by 2 R2, so this will be 0, this will also be 0, so another term will be 11 plus 3 by 2 into 7 by 12, so that is basically equals to 11 into 24 plus 21, which is basically 285 by 24, and the last term will be minus 36 plus 3 by 2 into 285 by 24. No, sorry, it will be 285 into 3 by 12. 3 by 12. So that will be basically 9 minus 36 into 24. That is minus 855 by 24. So if I simplify it further, I will get my system as minus 34017 by 12, 3 by 12, 0 0 1. I am using R3 as R3 divided by minus 95 by 24, that is basically minus 3, and here I am using my R4 as R4 divided by 285 by 24, so it is 1 comma minus 3 again. So if you see that row 3 and row 4 are same, so my determinant, so this must be equals to 0, because when two row or two columns are same, then determinant is equals to 0. So we have proved that the given equation of second degree basically represents a cone. So further we are supposed to find the vertex. So to find its vertex, for what we can do is we can just reduce it into a homogeneous equation. So let's do that. So it will be homogeneous in x, y, z comma t. So it will be equals to x square minus 2y square plus 3z square plus 5yz minus 6zx minus 4xy plus 8xt minus 19yt plus 8xt minus 19yt minus 2zt minus 22 square minus 2zt minus 20t square. So this basically a homogeneous equation of the given cone. So now we are supposed to solve del f by del x equals to 0. So this gives us 2x minus 6z minus 4y plus 8t minus 40t equals to 0. I have taken my t as equals to 1. Likewise, I'll get del f by del y equals to 0. From here, I'll get minus 4y plus 5z minus 4x minus 19t minus 40t equals to 0. Likewise, from del f by del z equals to 0, I will get 6z plus 5y minus 6x minus 2t minus 40t equals to 0. And the fourth one I'll get as I guess I'm doing something incorrect. Yeah, when I'm differentiating it with respect to t, I won't be getting these terms. So this is basically equals to 0. And likewise, when del f by del t equals to 0, I'll get 8x minus 19y minus 2z minus 2z minus 40t equals to 0. So this is what I got, and I know my t is equals to 1. So I'll just solve first three equations by substituting t equals to 1 and see what I get. So if I just put t equals to 1 here, I'll get 2x minus 4y minus 6z equals to minus 8. Likewise, if I substitute t equals to 1 here, I'll get minus 4x minus 4y plus 5z equals to 19. And from third one, I'll get minus 6x plus 5y plus 6z equals to 2. So if I solve these three equations, I'll get 1 minus 2 minus 3 minus 4 minus 4 minus 4 5 19 minus 6 5 6 2. So if I solve the sixth term of equation, I'll get 1 minus 2 minus 3 minus 4. I'm using r2 as r2 plus 4r1, so it will be 0. 4 to the 8 minus 12 and 12 4 is 12 minus 5, it will be minus 7, and 4 4 is 16. Here I'll get 3. Likewise, I'm using r3 as r3 plus 6 r1, so again it will reduce to 0, and it will be 6 to the 12. 6 to 12 minus 5 minus 7. Likewise, minus 18 plus 6 minus 12. 6 4 is 24 minus 2. Here I'll get minus 22. So if I further simplify it, I will get So if I further simplify it, I will get 1 minus 2 minus 3 minus 4, 0, 1, 7 by 12. Yeah, 7 by 12, comma 3 by 12, which is 1 by 4, and 0, comma 1, comma 12 by 7, and 22 by 7. So I have used elementary operation R2 as R2 by minus 12 and R3 as R3 by minus 7. Further, I can use R3 as R3 minus R2. So I'll get 1 minus 2 minus 3 minus 4, 0, 1, 7 by 12, 1 by 4, 0, 0, and 12 by 7 minus 7 by 12 will give 144 minus 49, which is basically 95 by 7, and it is 1. Is it 95 actually? 144 minus 49. So it is basically 95 by 7, and here I'll get 22 by 7 minus 1 by 4. So I'll get 22 into 4 minus 7, which is basically equals to 81 by 7 into 4. So if I solve it, I'll get I will get my Z as 81 by 7 into 4 into 7 by 95, which is basically here it will be minus 1 by 4. So it will be plus 1 by 4 here. So here I'll get, so 22 into 4, 88. 22 into 4 as 88, and plus I'll get 7, which is 95. So it is 95 by 28. So I got my Z as I got my Z as 95 by 28 into 12 into 7 by 95, so which is basically equals to 3. So my Z is equals to 3, and from here I can calculate my Y as 1 by 4. It is minus 1 by 4, minus 1 by 4 minus 7 by 12 into 3, which is basically equals to minus 3 minus 7 is a 21 by 12, which is minus 2. So I got my Y as minus 2, and from here I can calculate my X as minus 4 plus 2Y plus 3Z. So my X as minus 4 plus 2 into minus 2 plus 3 into Z as 3. So I got my X as minus 8 plus 9, 1. So my X is 1. Now we are supposed to put these values of X, Y and Z in the last equation that we got by differentiating F with respect to T, which is basically 8x minus 19y, 8x minus 19y minus 2z minus 40t. So this must, if this comes out to be equals to 0, then 1 minus 2 comma 3 is my vertex. So 8 into 1 minus 19 into minus t minus 2 into 3 minus 40. So 8 plus 38 minus 6 minus 40. So 8 plus 38 basically 46 minus 46, which is equals to 0. So 1 comma minus 2 comma 3 basically represents a vertex of given cone. So now let's move on to next question. So the next question says that find the section of cone whose vertex is P and guiding curve is this ellipse by plane x equals to z is a rectangular parabola. Show that locus of P is. So it is somewhat similar to the question that we have done. Just here they have changed the guiding curve. So let P alpha comma beta comma gamma be a vertex of given cone and L comma M comma N be direction cosines of any generator of cone. So if alpha beta gamma is vertex and L comma N is basically the direction cosines, then I can find equation of generator line. So that will be basically x minus alpha by L equals to y minus beta by M equals to z minus gamma by N. So if this is my generator line, it must be intersecting the guiding curve somewhere. So if it is intersecting guiding curve, then my z must be equals to 0. So using z equals to 0, I'll get x minus alpha by L equals to y minus beta by M equals to minus gamma by N. So from here I can find out value of x and y, that will be basically alpha minus L gamma comma N, and y will be basically beta minus M gamma by N comma 0. This point is basically intersecting point of a generator line in the guiding curve. So this must satisfy the ellipse which is the guiding curve. So from there I'll get 1 by a square into alpha minus L gamma by N square plus 1 by b square into beta minus M gamma by N square is equals to 1. So I can just put values of L by N and M by N from the general equation of generator line that we assume. So we'll get our equation of cone as alpha minus gamma into L by N will be basically x minus alpha upon z minus gamma square plus beta minus gamma into my M by N would be y minus beta upon z minus gamma square equals to 1. So this is basically my equation of cone which is passing via vertex this with and whose generator has direction cosine element and this is basically the guiding curve. So the question further says that the section of cone with x equals to 0 is a rectangular hyperbola in yz plane. So if I put x equals to 0 here, I will get 1 by a square into, first let us simplify it and then we'll put x equals to 0. So on simplifying it, I will get b square into z alpha minus x gamma square plus a square into beta z minus gamma y square equals to z minus gamma whole square. So we have section of cone with x equals to 0. So if I put my x equals to 0, I will get b square into z alpha square plus a square into beta z minus gamma y square equals to z minus gamma ka whole square. So with section of cone with x equals to 0 is rectangular hyperbola in yz plane. So coefficient of y square plus coefficient of z square must be equals to 0. So if I put coefficient of x square, So if I put coefficient of x square and coefficient of y square equals to 0, I'll get, from here let's just find coefficient of y square. This is no term with respect to y, so from here I'll get coefficient of y square as a square gamma square, plus coefficient of z square will be b square alpha square plus a square beta square minus 1. No, minus a square b square, because when we'll take LCM here we'll get a square b square as well, is equals to 0. So from here I'll get a square gamma square plus b square alpha square plus a square beta square minus a square b square equals to 0. So which is basically equals to b square alpha square plus a square into gamma square plus beta square minus b square equals to 0. So if I divide throughout by a square b square, I'll get alpha square by a square plus beta square plus gamma square minus b square by b square is equals to 0. So which is basically equals to alpha square by a square plus beta square by b square plus gamma square by b square is equals to 1. So this is basically the locus of vertex. So locus of vertex is x square by a square plus beta square plus gamma square by y square plus z square by b square is equals to 1. So this is basically the locus of the cone. So next question says that find the equation of right circular cone generated by straight line drawn from the origin to cut the circle that passes via point. Okay, find the equation of right generated by straight line drawn from origin. Okay, 0 comma 0 comma 0. So basically it is the vertex of the cone we are supposed to find. So let's say if this is my cone, so this is vertex origin, and any generator line passing via origin with direction cosine L comma n is basically passing via a circle which is passing via point A, that is 1 comma 2 comma 2, passing via point B, that is 2 comma 1 comma minus 2, and passing via point C, that is 2 comma minus 2 comma 1. And if this is basically the axis, so let L comma M comma N be DCs of my axis. So if these are basically direction cosines of my axis, then then angle between OA and axis and OB and axis and OC and axis will basically be same. So if we have direction cosines of axis, and direction cosines of OA will be basically 1 by 3, 2 by 3 and 2 by 3. Likewise direction cosines of OB will be 2 by 3, 1 by 3 minus 2 by 3, and direction cosines of OC will be 2 by 3 minus 2 by 3 and 1 by 3. Now I can use the formula which is basically for finding angle between two lines. So using that, if theta is angle, semi-vertical angle basically between axis and generator, so cos theta will be basically equals to L by 3 plus 2 M by 3 plus 2 N by 3. Likewise my cos theta will also be equals to 2L by 3 plus M by 3 minus 2 N by 3, and cos theta will also be equals to 2L by 3 minus 2 M by 3 plus n by 3. So 1 represents angle between axis and the generator line OA. 2 represents basically the angle between axis and generator line OB, and 3 represents angle between axis and generator line OC. So what we can do is we can just equate 1 and 2 and 1 and 3, and from there we'll get two relations in between LM and N, and then we can solve that using the cross multiplication method. So let us just equate. So if we'll equate, I'll get L plus 2m plus 2n by 3 will be equals to 2l plus m minus 2n by 3. So this I got by equating 1 and 2. So from here I'll get my equation as L minus m minus 4n equals to 0. This is by basically my fourth equation, and likewise I can equate 2 and 3. So equating 2 and 3, I'll get 2l plus m minus 2n by 3 is equals to 2l minus 2m plus n by 3. So if we solve that, I'll get 0 into L minus 3m plus 3n equals to 0. So this is my fifth equation. So if I solve my fourth and fifth equation, I'll get m equals to n, and if I use my m equals to n in fourth, I'll get my L as 5n. So from here I got my L is equals to m by 1 equals to n by 1. So this is basically my direction cosine, which is basically equals to L square plus m square plus n square under root 25 plus 1 plus 1, which is basically 1 upon 27 under root. So I got my L as 5 by under root 27, my m as 1 by under root 27, and my n as 1 by under root 27. So from here I got my semi-vertical angle cos alpha as L plus 2m plus 2n 1 by 3 into L 5 by under root 27 plus 2m plus 2n, which is basically equals to 9, which is basically 3 upon under root 27, which is equals to 1 by under root 3. So cos theta, basically I assumed theta as my semi-vertical angle. So I got my cos theta as 1 by under root 3. So if this is my semi-vertical angle, I got it as 1 by under root 3. So let us assume any arbitrary point P, X, Y, Z on cone. Let me draw it below as well. So if this is my cone, I got direction cosines of axis, basically m and n, and if I assume P as X, Y, Z, any point on generator, and I draw a perpendicular on the axis line, let us name it as m. So I cos theta, so my cos theta will also be equals to OM by OP, and since I have assumed my P as X, Y and Z and O is given to be as origin, so using distance formula I'll get my OP as under root x square plus y square plus z square, and OM is basically projection of OP on line with DC's LM and N, which are basically equals to 5 by under root 27, 1 by under root 27, 1 by under root 27. So OM will be equals to 5 by under root 27 into x minus 0 plus 1 by under root 27 into y minus 0 plus 1 by under root 27 into z minus 0. So from here I got my OM and OP both. So my cos theta is equals to 1 by under root 3 is equals to 5x plus y plus z by under root 27 divided by my OP as under root x square plus y square plus z square. So if I simplify it, I will get x square plus y square plus z square into 27 is equals to 3 into 5x plus y plus z whole square. So if I simplify it, I'll get 9x square plus y square plus z square minus 5x